Okay, in the last hour, we were discussing with data clouds, big data, data grids, and the use of internet, high-speed, wide area networking for connecting to data sets available in different locations and accessing them for computation, or rather sending them to the location where the computation is available, or sending computation facility where the data is available. All these aspects we have discussed in the last hour. Today we'll continue our discussion. Today we'll continue our discussion on technologies for data intensive computing. Okay, so in this data intensive computing, we shall see today storage systems, high performance distributed file systems, and storage cloud, and various storage clouds available from IBM, Google, Amazon, Sector, Lestray, and not only SQL systems. We shall see. As I was mentioning in the previous class also, the database management system which was being implemented earlier, the relational database management system, was not sufficient when the data is in an unstructured manner. The data is available in unstructured manner, the DBMS would not support the manipulation, management, access, process, mining of data when the data is enormous. The handling of data itself is a big issue. You can recall from the previous discussions of Unix systems, when you have implemented file operations in Unix, the files are being stored as a normal text file, and those text files are being handled using shell scripts. If you recall that, you will understand the importance of today's class. So in the database management system, you need to have a structured data, and you need to create them into tables, and then those tables need to be processed, accessed, and computation has to be done by creating queries. Okay, but in the case of data in the form of blogs or web pages or software logs or sensor readings or social networking data. Okay, so if such a data is coming in a in enormous scale and in an unstructured manner, then it was very difficult to do with the database management system. So how do we really do this? What are the popularity of storage systems in this case? What is the importance of data intensive computing when the data is coming in an unstructured manner is to be discussed. So data intensive computing concerns the development of applications that are mainly focused on processing large quantity of data. Therefore, storage systems and programming models constitute a natural classification of technologies supporting data intensive computing. So you need to have a proper mechanism to store data and process data, access data, and then programming models need to be there. So the programming model, either in the form of shell script, I said, so any manner in which the data can be read and processed. Since the three, four classes in earlier, we are discussing the similar problems of how to handle Facebook data, how to handle WhatsApp data, how to handle Twitter data, how people get the data and mine the data, and based on the mining of the data, how do they take a decision? So decision making model, how do they do it? All these are the point to note. Okay. So database management system was not, was not sufficient to do process of unstructured data. Earlier, for all types of applications, database management system was the only solution. Later, explosion of unstructured data in form of logs, pages, software logs, sensor readings, and other types of data, not only numerical data, non-numerical data also. How do they really process it? Even we have faced problems in saving photographs in our database management system. Suppose you want to keep a photograph and the database management system, you should have the facility. No? Similarly here, how much data, how much memory need to be allocated for that? Whether we need to keep as a link of data or the photo itself should be saved in the DBMS. This was the question when we were solving many projects. No? So please understand this. Okay. So unstructured data is not only numerical data, non-numerical data also need to be considered. That's what the software logs, sensor readings, and other things. It is unstructured, heterogeneous data, not a similar data will come, heterogeneous data. So how do we really handle that? What type of storage system need to be created for this is a question. So research on databases and data management industry are indeed a turning point. New opportunities arise. So I have already told you, big data analytics is the biggest area where you get lot of opportunity. Please go through this, study more on this, take some courses on this, and then it will help you a lot in your career, getting a good job in this area. Some factors contributing to this change are growing popularity of big data. As I told you already, management of large quantity of data is not, anymore a rare case. Okay, always you get, enormous amount of data wherever it is there. So that's why I've said the data-driven programming. You always think about, so lot of data is there. How do we really handle it? How do we really manage it? That is the biggest question. You can have lot of problems. You can identify problems, and you can try to find solutions to those problems. So either in scientific computing, enterprise applications, media entertainment, natural language processing, as you know already, AI and data analytics is a undergraduate course and a master degree course even in VTU. You see that, okay? So you need to think about earlier natural language processing was tough. Now each and every gadget has got a natural language processing, either in Amazon Echo or Google, Hello Google applications, Google apps. So you have wherever you speak and instruct the computer, instruct the gadgets, they will try to understand them and they will act accordingly. So natural language processing is that. How do they do really natural language processing? They need to keep a repository of data. Based on the repository, they need to understand the word you are speaking. So these are the things which you need to understand and remember. So natural language processing, social network analysis, all these large amount of data is coming, and analytics is the biggest problem in it, and it has got a lot of business in it. So that's why growing popularity of big data constitutes thinking of new storage system. Growing importance of data analytics in the business time. Okay, so you think about how do they really handle the data? How do they get a profit out of it? Based on the data, they try to get profit. As you know, when you search in Google, you try to search in Google. If you simply search, as I think I've already given this example, I'll repeat this example. Simply you type, I wanted to go to Delhi, which are the flights available? Just to give this search in your search engine, you will get a lot of information. Along with that, automatically you get a lot of advertisements in the right side of the page. How do they really do this? If they get the information, in that instance, they analyze your data, analyze your information. Based on that, automatically advertisements will come. Even if you, simply send a message to your friend that I want to go to Delhi, simply send it. Next day you see in the right side of your inbox, you will have advertisements related to flight bookings. So these are all, how do they really, every day, petabyte of data is being processed in Google. So that's what you need to understand. Okay, so either in Facebook or in Twitter, a lot of management of data, because in Twitter and Facebook, they mainly concentrate on user profiles, what are their interests, and how they are connected, what people they have connected, who are the friends of a particular person, and based on that, they'll try to analyze it, what type of information need to be shown to the particular user when they logged in. So all these are the business tactics. They need to do it. Based on that, they will have a lot of profits in that. Okay, massive amount of data which is constantly mined to get the analysis of data, and then try to do a lot of advertising business and other related things. So maybe you are interested in particular item. Amazon and Flipkart may give some suggestions. All these are the things which they try to lure you to get business out of you. Presence of data in several forms, not only structured. I already told you, data may be in any form. There is a text form or a non-textual form, numerical form, whatever may be the form. It is in the form of, it is not in the homogeneous format. It is in a heterogeneous format. That should be handled properly. Suppose you keep one photograph in your disk or in your mobile, maybe 2 MB, 3 MB, 10 MB file, they need to process that. How much time is required? How much, what information need to be extracted from that? All that are very, very important to note. Okay, so heterogeneous data comes, and that data needs to be processed. Structured data is constantly growing as a result of continuous use of traditional enterprise applications. But because of heterogeneity, so the current technology may not be useful, but we need to create a new technology. So new approaches and technologies for computing need to be deduced, created. So cloud computing in this area, cloud computing promises access to massive amount of computing facility and demand. This allows engineers to design software systems and incrementally scaling. Scaling of your technology also come into picture, and they try to add parallelism into it. So we have already discussed in six chapters. We have discussed about parallel processing, how high performance computing they go. 7th chapter also we have seen that, high performance computing, how do they really do it? And all these things you need to remember, it's all based on your distributed data management system, distributed data management system. So you need to think about not only a single database or a data set, it is in the form of a distributed manner. That is also to be considered here for understanding about storage system. So storage system should have the capability of supporting all these factors for better processing of data and better business. Advances in a distributed file system for the management of raw data in the form of files, distributed object stores, the spread of NoSQL. NoSQL is not only SQL movement, constitute not only SQL. SQL is used for traditional database management system, relational database management system. NoSQL means not only SQL is an acronym for NoSQL. Not only acronym NoSQL can be expanded as not only a SQL system, not only SQL movement constitute the major directions towards support of our data intensive computing. So high performance distributed file systems and storage clusters. See, again, look at it. So we have discussed high performance computing. Now we are discussing high performance distributed file system. So the even accessing of data, the file system, you network attached storage or SAN, you are studying that, storage area network and network attached storage, NAS, SAN and NAS, you are studying in another course. So you will get more information about this in SAN and NAS courses. Okay, high performance. The data need to be connected, data need to be accessed, data need to be processed in very fast manner. So that's what the discussion here. Distributed file system constitute the primary support for data management. They provide an interface where to store information in the form of files and later access them for read or write operations. So now we are thinking in the form of files. Underline that. In the form of files, not in the form of tables. In relational database management system, we were saving all the files, all the data in the form of tables. Now we are saving information in the form of files and later access them for reading and writing operations or editing, modification operations. Among the several implementations of file systems, few of them specifically address the management of huge quantity of data on a large number of nodes. Hey, look at it. Now, because it is in the distributed manner, so each node will be keeping a lot of information. Okay, how do we really handle them? How do we access them? What is the way to access the data? How to fetch the address and get the information from that? How do we really manage the data? Maybe you need to create data first, manage data first, destroy data next. So in your data structure, all the four primary operations need to be creation, insertion, deletion, okay, and modification of data or appending of data. You need to think about it, or manipulation of data. Okay, so these are the important things you need to remember. So there are so many storage clouds available. High performance distributed file systems or storage clouds are available. One after them we will move on. So first one is LetsTray. The LetsTray file system is massively parallel distributed file system. Look at it. It is a massively massively parallel distributed file system that covers the needs of a small work group of clusters to a large-scale computing cluster. So you just see, here cluster management came, grid also, grid and clusters will be there. Work group of clusters, so collection of clusters is a grid. So you are getting it, grid computing came into picture here. Again, it is massive, so the quantity is heavy and it is a parallel processing distributed system. So good. All concepts have been added here. Massive data system, parallel system, and it is distributed file system, as well as it is considered as a computing cluster also. The file system is used by several of the top 500 supercomputing systems, including the one rated in most powerful supercomputer in 2012. LetsTray is designed to provide access to petabytes PBs of storage to serve thousands of clients with an I/O throughput of hundreds of gigabytes per second. So, hundreds of gigabytes per second, GB. So, gigabit means bit, it will be a lowercase b. Capital B is a gigabytes, okay? GBps, okay? That is one character per second is a byte per second. Actually, 1024 megabytes, mega characters, 1024 mega characters per second will be 1 Gbps. So hundreds of gigabytes, 100 Gbps. Understand this, okay? So much of data speed will be there to access the data. So that's why it is high speed, highly parallel, massively parallel, and there are multiple clusters available to access the data, and it is top 500 supercomputing system. The system is composed of a metadata server that contains the metadata about the file system and a collection of object store servers that are in charge of providing storage. So that is the mechanism in which the LetsTray works. Users can access the file system via POSIX compliant client, which can either be mounted on a module in kernel through a library. Please note this. See, POSIX, client, kernel, all these are the basis of Unix file system. So the underlying operating system must be a Unix file system. Based on that only LetsTray works. Remember, this POSIX compliant client means it is Unix based kernel. The file system implements a robust failover strategy. Please remember here, whenever you are accessing the data, something happens to the data. While reading the data, something happens to the data. How do we recall it? How do we recover it? How do we handle it? That is the failure. If failure occurs, how do we really come back to solve the problem? So, failover strategy. If there is a failure, automatically the recovery mechanism need to be established, and then the loss of data need to be created, reconnected, retransmitted. All these things need to be taken. That is a fault tolerant mechanism need to be established, making server failures and recoveries transparent to client. Okay, these are the things about Lustre file system. Next is IBM General Parallel File System. We call it as GPFS. It is a high performance distributed file system developed by IBM, providing support for, see, you may recall DB2 was the IBM database engine, and now they also shifted to heterogeneous file system or a distributed file system. How to handle it, they created General Parallel File System. Earlier it was a Relation Database Management System, the DB2 IBM, and now we have a GPFS. It is for high performance distributed file handling. It provides support for RS-6000 supercomputer and Linux computing cluster. Again, look at it here. Again, it comes with a Linux operating system, Linux platform. They have implemented this. GPFS is a multi-platform distributed file system built over several years of academic research and provides advanced recovery mechanisms. Again, whenever you are thinking about it, you need to think about fail-safe recovery, remember this. Okay, GPFS is a built on concept of shared disk in which a collection of disks is attached to the file system nodes by means of some switching fabric. So you will have several disks. See the mechanism here. Internally, how the data need to be saved. Maybe in our database management system, how do we really do it? No, it's a collection of so many disks. The diagram, the picture shows like the database, there will be several circles. So each circle is considered to be a disk. So it is a shared disk. One collection of disks is attached to file system. There will be a switching fabric. That's a storage area network. You can easily understand that. It is a storage area network, and the data will be accessed through that. So there is a mechanism to access data from a particular disk, because all disks are shared in nature. GPFS has got the mechanism to access these data. It is connected through some networking element. Okay. The file system makes this infrastructure transparent to users and stripes large files over the disk array by replicating portions of the file to ensure high availability. The file system makes this infrastructure transparent to the user, transparent to the end user. Only here you are trying to understand. When the user who is using this IBM GPFS, he will not be knowing how the data is coming, how data is being transmitted, how data is stored, managed, mined. All those things are very transparent to the end user. He will not be able to see the information inside, but he will only get the information required. So stripes the data large files into disk array by replicating portion of the file to ensure high availability. The problem here is, see, when the files are being stored in different locations, as I already told you in the beginning of my discussion of cloud computing, I told you 3 locations the data will be saved over a network. Google saves, Amazon saves in 3 different locations, so that if any one link is failure or any one server is failed, the data can be accessed from other servers. So that is the main reason to create business continuity plan, that we call it as BCP, business continuity plan, or disaster recovery plan. Then all these files will be saved into different locations. So this is here again, the file will be replicated. The replicated portions of file will be saved into different locations to access high availability. By means of infrastructure, the system is able to support petabytes of storage, which is accessed at a high throughput without losing consistency of data. So again, you need to maintain integrity here. When the data is saved in different locations, you need to worry about confidentiality, you need to worry about authentication, you need to worry about availability. All those concepts of cryptography, again, here it comes into picture. You need to have security over data. Compared to other implementations, GPFS distributes the metadata of entire file system and provides transparent access to it, thus eliminating a single point of failure. Look at it here, very, very important note for in all these concepts, in all these high performance distributed file system, three important things, one is security, one is availability, one is access and availability, another one is fail safe, okay, reliability. So these are the important things you need to note for whoever is the service provider, data service provider. So whenever you are understanding data as a service, that is called DaaS. These are the fourth pillar of your cloud computing. IaaS, PaaS, and then software as a service, correct? Infrastructure as a service, platform as a service, software as a service. What we are understanding now? Data as a service. Okay, we'll go to the next. Next we have Google File System. Very, very important, very interesting. Google File System, GPS, GFS file system. So GFS is a storage infrastructure that supports the execution of distributed application in Google's computing cloud. Google uses Google Cloud and it uses Google File System for handling it. Because of this only, all are at your fingertip. So my, Office, Word, Excel, PowerPoint, and the meeting which we are doing, see, it is being recorded, the video, the class is being recorded and it is being saved in the Google Cloud. For all these things, the Google is supporting the distributed application. We are sitting here, you are sitting at your home and we are accessing Google and the recording will be saved in some Google Cloud and you can access, after the class also you can access the data. So this is how it is being done, Google helping us for creation of such enormous amount of data. The system has been designed to be fault tolerant, highly available, distributed file system built on commonly hardware, standard Linux operating system. The third one I'm explaining now, the Linux operating system, Unix operating system. So how robust is the Unix operating system to support distributed environment? Remember this. So find more lucrative opportunities in the Linux environment. Learn more about Linux environment. You will have your bread and butter. So Google File System has been developed with some of the following assumptions. The system is built on the top of commodity hardware that often fails. The system stores a modest number of large files. Multi-GB files are common, should be treated efficiently, and small file must be supported. Small file also should be supported. Large files automatically it should be supported. Okay, but there is no need to optimize for that. Workloads primarily consist of two kinds of reads: large streaming reads or small random reads. So in reading also you have two types. One is a large streaming of data. So you should have a mechanism to read a streaming of data, or if you need to read only certain portion of the data, that is also need to be considered. The workloads also have many large sequential writes that append data to files. So sequential writes are there that append to data to files. Because of this only you can easily understand, while working with Google Files or Google environment, have you ever saved your files? Control S, you have to press. When you are working with your computer, you should press Control S. Because of power failure, you may lose your data. But in the case of Google, you have never pressed Control S. How do they really do it? Think about it. Every fraction of a second, every particular interval of time, it is automatically saved, and it is saved into multiple copies also. You can get back the legacy of your data storage, data correction, data modification also can be seen. High sustained bandwidth is more important than low latency. So it is very, very important. factor in which the Google is relying, high sustained bandwidth is more important than low latency. So they are not worried about latency. They are not worried about delay in your data communication, but they are worried about the bandwidth. How much bandwidth is given to GFS is an important point to note. Okay, so in the architecture of file system, it is organized as a single master containing metadata of the entire file system, the collection of chunk servers which provide storage space. From a logical point of view, the system is composed by a collection of software daemons which implement either master server or chunk server. A file is a collection of chunks whose size can be configured at the file system level. We'll discuss more on Google Files. Okay, we call it as big table, Google big table. Maybe in the next class we will discuss about that. How Google file system or Google big table is created, what will be the size of each big table, how do they access it, how do they give data from big tables, we'll discuss. This is how it is created. So there are two file systems. One is a master server, another is the chunk server. Chunks, a file is a collection of so many chunks whose size can be configured at the system level. Chunks are replicated on multiple nodes in order to tolerate failure. So failure tolerance is there here again by making multiple copies of the same file at different locations. Once the chunk is identified, the interaction happens between the client and the client server or chunk server. Applications interact with the file system with a specific interface supporting the usual operations for file creation, deletion, modification, read, write in the applications. Okay, GFS, the Google file system, has been conceived by considering the failures in a large distributed infrastructure are common rather than rarity. So when you are having a distributed environment, most of the times you will have some failure. So the failure need to be handled properly. That is the big motto of GFS. Okay, so implementing very highly available, lightweight, fault-tolerant infrastructure is a order of the day. So Google has given that type of application development or data access system development. So that is how GFS goes on. We'll discuss about Google Big Table in the coming classes. Okay. Next is Sector, another important file system and a storage cloud. Sector is the storage cloud supporting the execution of data-intensive applications defined according to the Sphere framework. It is a user space file system that can be deployed on commodity hardware across a wide area network. Compared to other file systems, Sector does not partition a file into blocks, but replicates the entire file on multiple nodes. This is another strategy. Instead of having a copy of pieces of or the portion of the file into different locations, Sector copies the entire file in multiple locations. So you can access the file directly. There is no verification of consistency of data because the complete file is available at a location. So no need to worry about replication or duplication of data. So entire file can be accessed, entire file can be saved, allowing users to customize the replication strategy for better performance. That's what. Consistency need not be worried. Repetition of data need not be worried. Duplication of data need not be worried. But replication of entire file into the system will really help the performance, improving performance in Sector storage cloud. The system's architecture is composed of 4 nodes: a security server, 1 or more master nodes, slave nodes, and client machines. So that is the architecture of Sector. There will be a security server, 1 or more master nodes, slave nodes, and client machine. So directly client machine will access the information from slave machine. Master will copy information to the slave machine, and then they will manage the data. Okay, clients which ultimately interact the slave nodes for accessing a file. A protocol used to exchange data with slave nodes is UDP, which is a lightweight, a connection-oriented protocol. So next one is, so we'll conclude our class with Amazon Simple Storage Server. Amazon S3 here. Amazon S3 is the online storage service provided by Amazon. Even though its internal details are not revealed, the system is claimed to support high availability, reliability, scalability, infinite storage, and low latency at commodity cost. So what are the things you require? Everything is available here. Highly available, reliable, scalable, and it is secure. As Amazon and Google, they always mention they have got a security mechanism adopted is with a 99.49.49 security. They call it as .49 security means 99.9999% secure. Maybe 0.0001% is not secure. It is always there every time. How you, after locking also, you will verify whether it is locked. Same thing will be there. So always that 0.001 risk will be there with any of the databases or data storage systems. The system offers a flat storage space organized into buckets, which are attached to an Amazon Web Service AWS account. Amazon Web Services. So you always think about joining Amazon, where you will be working with Amazon Web Services. Remember, to study more on this S3. Each bucket can store multiple objects, each identified by a unique key. So based on the key, the data will be accessed. So it is something like associative list of objects. So each object will be having a key. Based on the key, the objects will be accessed. Objects are identified unique URL and exposed through HTTP, thus allowing very simple get and put semantics. So that's what in the beginning, how the files need to be saved into your database, whether it should be saved as a link to some location where the actual file is available, or the file itself need to be saved. Please understand here, you will understand how we have asked you to upload your fee receipts in Google form. You have stored your data and you have put Google link in the file where Google Forms are created. So in the Google Form, you have given the link where the file is saved. So here also same thing. Objects are identified by unique URLs and exposed through HTTP. Normal HTTP or HTTPS is being used to access this data, just allowing very simple get put semantics. Okay, so I'll stop at this point. Now the floor is open for question answers. You can ask me any questions, then I'll try to answer.